Hello, welcome back. I haven't been here for a while. Yeah, at least a week. Yeah. Got 2 Lukes and 1 Lana. Big into L's today. Yeah. A lot of L people. Okay, I'll buy a vowel. Okay. I want to make a 4-hour video. Just kidding. Somebody asked me about kinetic energy, potential energy, kinetic energy changes, the difference between kinetic energy and potential energy, and potential energy changes.
Students taking the 3:15 late bus, please report to the bus port and cafeteria at this time. All students taking the 3:15 late bus report to the cafeteria at this time.
What were we just saying? I have no idea.
You're saying the change in potential energy?
The change in potential energy versus the change in kinetic energy, then just kinetic energy versus potential energy, okay? So let's draw a rocket going up, okay? Now, I'll just put some numbers for kinetic and potential energy. I'm going to put 3 places here. I'm going to put point A, point B, point C, okay? Just 3 points. Now, at this point, I'll say at A, the kinetic energy equals 5,000 joules. The potential energy equals 0. Okay? Is that good? You with me?
Yes.
Okay, now, up here, I'll say the potential energy, the kinetic energy equals 0, the potential energy equals 5,000. Correct?
Yes.
Easy? All right, now, down here, I'll say C, I'll say kinetic energy equals 5,000 joules, potential energy equals 0. All right? Easy? Yes? All right, now. So these values are not they're not negative or positive. They're just values. They're heat content. Clear? When I talk about, you only have negative or positive potential and kinetic energy when you're talking about change. A change in kinetic energy. Or a change in potential energy, right? So a change in potential energy is going to be potential energy final minus potential energy initial. Can you read that? Does that come off on the thing we do, Vicky? Is that all right?
Yes, it does.
Okay.
Perfect.
All right. And then the change in kinetic energy is going to be the kinetic energy final minus the kinetic energy initial. Okay? Easy? Are you with me? Yes? Okay. So let's look at 2 places where we have a change. Okay? And we'll look at the kinetic energy and the potential energy change for each place. Okay? All right, now, to look at a change, you need a beginning and you need an end. You need an initial and a final. So when you're talking about a change, you got to compare 2 things, right? Right? You got to compare 2 things. All right, now, so we're going to do, the first thing we're going to do is change in kinetic energy going from A to B. A to B. Okay? So do you see that that's going to be final minus initial?
Yes.
0 minus 5,000. Yes?
Yes.
Kinetic energy, they're not vectors. They're not vectors. Correct? They're scalar quantities. How much heat? Right? But it's a vector only if you're talking about a change. Yes?
Yes.
That's not really a vector even. It's just a sum of heat. It can actually denote flow. I suppose it could be a vector in a sense. You could argue that it could be a vector. It's really not.
But it's not going in a particular direction.
But it's more, it's a vector in terms of its flow, like the vector of a virus. What's the vector? In other words, how is it spreading? Is it spreading north? Is it spreading east? Is it spreading west? When we had, quite a few years ago, we had a bloom of rabies. And what the rabies did was it came up from the south. It didn't cross a river. It doesn't cross rivers. It came up from the south, came up to New York State, Pennsylvania, into New York, and then came around down to New Jersey. It took a while to get down to here. They had to come up from the southern United States and then around and then down. Okay? That was the vector. What was the vector? The vector was really the south. Came up from the south. That was the vector. Okay? So you could think of that as a vector, as a spread of a disease. So you could maybe talk about the flow of energy, but that's not really a vector. Okay? Now, so that's going to be negative 5,000 joules. You see that? That's going to be negative 5,000 joules. Any problems with that?
No.
Okay. The potential energy change, right, is going to be A to B is going to equal what? Final minus initial.
Positive 5,000.
Positive 5,000. Very good. Positive 5,000 joules. Okay? Easy? Yes? Yeah? And now, let's look at down here. We'll do it another color. We'll do it magenta. Huh? Magenta. Okay. Magenta. All right, so we'll write down here. So this is going to be potential energy, kinetic energy change going from B to C. Going from B to C. Easy? So what's the kinetic energy change going to be?
Negative.
Careful. Final minus initial.
Positive.
Positive 5,000. Okay? What's the potential energy change?
Negative 5,000.
Going from B to C. Negative 5,000 joules. You see that?
Yeah.
So both the change in potential energy and the change in kinetic energy, they can both be positive or negative. It depends on what you're comparing.
Yes.
It's final minus initial. So if it's losing energy, it's negative. If it's gaining energy, it's positive, right? Look, kinetic energy, it lost kinetic energy, right? So it's negative, right? Here it loses potential energy. So negative means lost. Positive means gained. You see that? For change. For change. Cool? Is that good? Is that a good way to describe it?
That's
Yeah?
fine.
You like that?
Yes.
Change. Nothing more satisfying than to draw a large triangle. Something very weird about that, don't you think? Very strange. Okay, so that is going to be a review of potential and kinetic energy. Now, word of warning to the viewing audience out there. I really don't know what I'm going to name this. Probably, I don't know, test review 4, right? Right? Work energy and silk machines test review 4, right? So if this goes off, I'm going to name that part A,
Okay.
and then test review work energy and silk machines 4, part B. Okay? All right, so let's continue. All right, now, take out worksheet problem set 6, okay? And I'll clean up over here, okay? Clean up here. Okay, we ready?
Yep.
Okay, so midge, okay, is being pulled up a mountain. Clear? Being pulled up a mountain. Is that okay? All right, now. Now, the mountain is at an angle with the horizontal of 12 degrees. The snow, pretty slippery. Not really slippery, but pretty slippery. You know, 0.12 is slippery, but it's not unusually so. Anything below 0.1 would be slippery. 0.12, not too bad. So the coefficient of kinetic friction is 0.12. Yeah? What else do we know? We know her mass, correct?
Yeah.
$60 kilograms.
Yes.
I'm going to say something to someone in my period 2. They know who they are. If I asked you how tall you are, and you said to me that you were 55 miles an hour, would that make any sense to you? Right? If I said that you are 60 kilograms, is that your mass or your weight?
That's your mass.
That's your
weight.
Be careful.
Is it your mass?
You see, she's doing it too.
It's
It's your mass.
Your mass.
Kilograms are mass.
Okay, yeah, newtons.
Remember the problem today? It was
Yeah,
like
newtons.
25 newtons. What was it? It was 100 newtons. So people multiplied that by 10,
Okay.
right? Well,
Yeah.
you didn't need to because I gave it to you in newtons.
You already gave us.
Yeah, like if I said that you're like 5 foot, right?
Yes.
Is that how much you weigh?
No.
That's how tall you are.
This is horrible.
Yeah. So if I asked you how tall are you and you said you're 110 pounds, that make any sense?
No.
Or I said to you, I am 1,000 newtons, and you said, oh, I didn't realize you were that tall. Okay? Now,
Okay.
so it's 60 kilograms, so that's a mass, right?
Yes.
All right. So let's draw our famous triangle,
Oh.
our triangle resolution of this
Yeah.
particular problem, okay? So it's going to be okay. I don't really want to have to explain what all those are. I think we're beyond that. You would never have known it today, though. It was a very tough day. My students were very, nah. Okay. All right? Okay. It's like they're coming back from like a 3-year vacation. It really was like the first day of school today. Why? It was like a Tuesday. Weren't you guys like weird today?
I mean.
Like period 8, remember period 8?
Yeah.
I mean, you guys were like, it was really weird. It was really weird. It was like Twilight Zone.
That show.
So what's FN, FP,
Okay, so.
F? Do all the Fs. You got to go F.
Okay, yeah.
That doesn't work.
Because FW is.
Okay, good.
60
Wait a second. Let's do the Fs.
Okay.
FW
Is
is
60 kilograms times 10, which equals 600 newtons.
600 newtons.
Which is the weight.
Which is the weight. Good. And what is FN?
FN is 600 cosine 12, which is.
586.
586. Excellent. Excellent. What's FP?
Is
What's FP?
125.
What is it?
125 newtons.
Excellent. Excellent. 125 newtons. Okay, can you see that? Everybody can see that? Okay.
yes.
All right. What else? We need FF. I'm kind of like, everything's kind of like all over the place here, right? You can deal with it?
Yes.
What's FF?
70 newtons.
70 newtons?
Well, negative 70, right? It's negative.
Yeah. Yeah. And this is -2, right?
Yes, it is.
Well, why do we know that that's negative? Let's not get ahead of ourselves.
Because the friction is in the opposing direction of
Yeah, what in the problem, isn't it 200 newtons are applied to the skier,
Yes,
right? Which way is that? That's up the mountain, right?
yeah.
Okay? So it says in the problem 200 newtons are, what does it say? Give me the wording. Give me the verbiage.
Okay, the snowmobile exerts a force of 200 newtons parallel to the hill.
All right, applies 200 newtons parallel to the hill going up. Okay? So 200 newtons, so that's F, A. These are just not working today. I'm like, can you see that?
Not really.
That's not working. That's not that great either, is it?
It's better, but it'll do.
Is that all right? We're having a marker gap. We like to talk about gaps in the 60s. We had a gap. Gaps. Okay, we use red instead. Okay, so 200 newtons. That's the applied force.
Yeah.
That's FA. Correct? Is that good? Cool? There. Good. Yeah? All right, now. So, what else?
The force of friction opposes that direction of motion.
Well, what's force of friction? Oh, we got the force of friction, right? Okay, so very good. So this is force P, and that's force F. So this is the friction, and that's the parallel force,
Yeah.
right? That makes it kind of want to, like if you let go, that's the force that's going to want to like, yeah, you want to make you go down the hill, right?
Yes.
We call it FP, push, pull, parallel, however you want to say it, okay? All right, so we got a lot of stuff on the board here, don't we?
Yes.
Yes? A lot of stuff on the board. You know what I want to do? I want to come back. Is that okay? I want to clean everything up a little bit, okay? Do you see what we did? Let's see, what did we do? We got, that's given, that's given, that's given,
And
given, what else? Given,
and that-
right?
Yeah.
And everything else is calculated.
Yeah.
So I'm going to quit, and we're going to come back,
For part
make
B.
everything nice and neat.
Okay.
Part B, as in Bravo Company, okay? Be right back.